Hey everybody, Trey here. Welcome back to another video. Back with another forecast discussion for today. We have a slight risk, level 2 out of 5, for parts of the southern plains from the eastern Texas Panhandle and western Oklahoma southward into central Texas down toward the Texas-Mexico border. All hazards threat for today, tornado threat. This has been downgraded in this latest outlook. It was a 5% up here for northwestern Oklahoma, but some lack of confidence in convective evolution today has downgraded the tornado threat to a 2% from the eastern Texas Panhandle into the western half of Oklahoma into far northwest Texas. We'll talk about the lack of confidence in today's forecast here in just a second, but there is a tornado threat with the storms today. Damaging winds going to be a threat as well, and large hail, perhaps significant hail, especially down with southern extent within the slight risk area, the area from Austin, San Antonio westward toward the Texas-Mexico border, most at risk for some significant 2+ inch hailstones today. So let's go ahead and get started. This is a very complicated setup, and we'll start off with our water vapor satellite imagery, as we always do. And you'll see right off the bat we have a swirl here that is centered over Southern California. And this Southern California swirl is part of a larger trough that is moving in from the west. But this is not going to actually influence our weather for today's event. You see this plume of southwesterly flow here out across Texas, impinging into Oklahoma and Kansas. This is on the nose of a lead shortwave that has emanated from the subtropical jet. If we look at our 500 millibar map, you'll see exactly what I'm talking about. This is our trough back in here across the western half of the country, centered across California here at this point. But this is still way back to the west from our target area. Target area here again is western Oklahoma down into central Texas. This little plume of stronger winds, this blue shading down here, is a little shortwave trough out ahead of this main wave back in California that is going to be our main focus, main driver for severe storms today. This is a piece of what's called the subtropical jet. We have two jet streams we typically discuss in meteorology. You have the polar jet stream, which is displaced farther to the north, and then you have the subtropical jet stream down here in the down to the south, much closer to the equator. And a piece of this is broken off, and this is going to be our main player for severe weather today. You see a little bit of a kink in the flow here associated with the shortwave, a little bit of enhanced flow aloft as well. That is going to be our main synoptic scale forcing mechanism for storms for today's event. Now, there's also been some concern over morning convection and what impacts it might have on the overall threat. This has been a bugaboo in the forecast for the last couple of days. So let's take a look at what's going on right now. This is our satellite imagery, and you can see widespread cloudiness out ahead of this subtropical jet shortwave. Basically Oklahoma and Texas are socked in clouds right now, and as we know, we want to see that sunshine. If you're looking for severe weather, you want to see that sunshine help bake that atmosphere, bake the low levels of the atmosphere, build that instability. And this may be a concern for today. And if we look at our radar, you do see quite a bit of activity going on. We had some severe storms in the Texas Panhandle last night that formed into an MCS. This has since moved off into Oklahoma, and this, I believe, is the remnants of that MCS. You can see it propagating likely along some outflow there into eastern Oklahoma, some redevelopment behind that in southern Oklahoma, and then we also have some showery activity with some embedded storms out here back in the Texas South Plains to the southern Texas Panhandle. This is all moving off to the northeast, and it remains to be seen what impact this is going to have on today's convection. This is the main complicating factor for today's convection and our severe threat for today, is how is this going to progress throughout the morning? Is it going to move out quickly? The main thing to remember is that if this moves out quickly, in other words, if we get these storms to dissipate or clear out and these clouds to move out fairly quickly this morning over the next few hours, we will see a greater chance for instability, or at least robust instability, to build. And therefore, the atmosphere will be fairly untapped for severe storms later this afternoon. That would increase the overall severe threat. If these storms stick around and these clouds stick around, we have redevelopment of storms back here. They continue to move through the area throughout the next several hours into the early afternoon even. Then we will have a lesser chance for robust instability to build, and therefore we'll have a severe threat that will decrease overall. And that's the main reason why they've downgraded. The SPC has downgraded the overall tornado threat from a 5% yesterday now to a 2%. Just not sure about the evolution, especially up here in the northern portion of the risk area. If we go to the southern portion of the risk area, it's going to be much more untapped by any clouds or storms into the afternoon. We'll go back down to our southern sector here into central and southern Texas. We do have quite a bit of cloud cover out ahead of that shortwave trough here, so that is going to be an issue for the entire risk area, but I do believe that will clear out as we go into the afternoon, especially for areas to the south here across northwest down to the northwest Texas down to the Texas-Mexico border. We don't have quite as much activity down here emanating from Mexico. We may see some showers here in the morning, but these should much more easily move out down here. And that's why instability will be more robust here across southwest and central Texas, and therefore we will have a significant hail threat with supercells down here. So the northern portion of the risk area is going to be where the lack of confidence lies in this portion here, eastern Texas Panhandle into western Oklahoma and even northwest Texas. Down here, a little bit better chance for destabilization, at least robust destabilization, and therefore we should see a greater severe threat down there, at least a little bit less complicated severe threat down there. So let's go back to our upper air maps here, and so we'll take a look at our low-level jet. We should have a nice decent plume of low-level jet here across the Texas Panhandle, fairly narrow plume, and would not expect this to really increase much throughout the day given a fairly limited upper level pattern here. Just you have this very subtle shortwave traversing into the Texas vicinity, so not much going on here in the upper levels to initiate that strong lee cyclogenesis somewhere in eastern New Mexico or southeast Colorado, although we will see surface low development somewhere out in here in southeast Colorado to some extent this afternoon into evening. You can already see a little bit of that cyclonic curvature there in the 850 millibar contours there. So we do have some semblance of a broad low-level cyclone in place already, with some semblance of low-level jet, although not too much. And that is going to keep low-level shear down for today across the region, especially away from the surface low and surface warm front, which we'll talk about in a second, which should lead to more of a large hail and damaging wind threat with any supercells in the open warm sector, especially with southern extent away from those features down the dry line, especially into Texas. Tornado threat will decrease with southern extent into Texas, given fairly straight photographs. Let's go down to the surface, show you what's going on down there. We do see that semblance of surface low there in southeast Colorado. That should somewhat strengthen throughout the day and allow that warm front to surge northward. That leading northern edge of the moisture return, you see a little bit of a wind shift there, a little bit of a kink. We may have at least actually about two of these warm fronts. It's hard to tell. This northern one here, this little kink in the flow, may be outflow reinforced. If we take a look at our surface data here, you see a fairly chaotic surface pattern. So we have established our surface low here in southeast Colorado. We do see some semblance of wind shift here in northern Oklahoma. Across central Oklahoma, winds out of this almost due south, shifting to more southeasterly here in northern Oklahoma. This may be a result of that ongoing storm complex across eastern Oklahoma. Remnant outflow boundary from that could have played a role in the wind shift up in here. Then we have our secondary warm front, that leading edge, that northern edge of the moisture return, that is situated down here across northern Texas. A little bit tricky to pinpoint, but we do see a wind shift here. Southerly winds across much of central Texas, shifting to, along the Red River, at least more easterly winds. So your synoptic warm front is probably somewhere in this vicinity right here. So that is going to be the leading edge of the moisture return. You see those upper 60s dew points, those mid to upper 60s dew points. Still confined down here south of the Dallas-Fort Worth Metroplex. We have a 66 reading here. That may be a little bit erroneous, although Austin right there is also 66. So we may have a narrow corridor of that higher moisture return in there. That will make its way northward as we go through the day. That surface low strengthens just a bit in southeast Colorado. That will bring that moisture northward and allow for that moisture transport into places like the eastern Texas Panhandle and western Oklahoma. So the northward extent of the warm sector will be a little bit more narrow. That warm sector, that better moisture, will be a little bit more narrow down here, much broader down to the south, ahead of that dry line that will set up later this afternoon. So we will have a fairly broad area for favorable low-level juiciness, if you will, for severe storms, but that will decrease in width as you go northward into western Oklahoma. Let's go down to our soundings now. Looks like Norman did not release a 12Z sounding. We do have a Lamont, Oklahoma sounding, which is in far northern Oklahoma, so we'll take a look at that real quick to show you what's going on here with the morning weather balloon. So we have an interesting profile here, fairly moist profile up through the atmosphere, a little bit of elevated instability perhaps atop this fairly stout capping inversion in the low levels. This is well to the north of that better moisture, obviously 56 over 51, so not super representative of our environment in the open warm sector. If we go down to the south, let's go to Dallas-Fort Worth and see what's going on. You see a little bit more low-level drying there, a little bit more of a stout elevated mix layer. That's that layer of warm, dry air aloft that emanates from the desert southwest and western Mexico, gets transported off to the northeast, atop that moist layer and in the plains or wherever your setup is, and that allows instability to build and the warm sector to remain free and clear of storms throughout much of the day. Now we do have this shortwave that has allowed storms to fire out across Oklahoma into West Texas this morning. These storms are elevated. These will not pose much of a severe threat this morning, but they may have an impact, as we talked about, on the overall threat going into this afternoon for our main show. So we do have some elevated instability in place there across Oklahoma that is fueling those ongoing storms, but not a profile here that necessarily screams significant severe weather for you. Let's go down to Del Rio, a little bit better down to the south here. This is what we call a loaded gun type sounding. Elevated mix layer here, a little bit of that drier air, well-mixed air aloft, atop a nice deep moist layer, 75 over 63, with a moist layer that extends up into the atmosphere above about 850 millibars. So this is a loaded gun sounding, already quite a bit of instability in place, 1400 joules per kilogram of mixed layer CAPE already, with that capping inversion in place. That's why the instability down to the south is going to be a little bit more robust in the areas that have been untapped by convection this morning. Photographs a little bit on the less favorable side for at least tornadoes, at least now. That will change as we get that surface low to strengthen, especially with northern extent across southeast Colorado and then down into the Texas Panhandle and western Oklahoma, where near that warm front. Low-level shear, a little bit of low-level shear this morning, not too much to speak of. Deep layer shear on the margins for supercells at this point, 31 knots, but as that stronger flow aloft makes its way in, especially for areas down to the south in Texas, we will see deep layer shear increase, and therefore the overall threat for supercells will increase as well. Let's go into some model data now. This is the 12Z NAM coming in as we speak. Let's take a look at our initializations here at 500 millibars. Nice plume of that subtropical jet in place there here at 12Z, which would be 7 a.m. Central Daylight Time, recording this at about 9 a.m. So we move forward into the afternoon. That plume of stronger flow aloft, that little shortwave associated with that subtropical jet, moves into Texas. You see that little kink, that little subtle kink in the height contours there associated with that shortwave moving in. So, and you see your stronger flow aloft is concentrated down here across basically the Texas portion of the risk area. Farther to the north in northwest Oklahoma, originally where that 5% tornado risk was, not much upper flow here. You have to go down to southwest Oklahoma really to get into that area of best flow aloft, strongest deep layer shear for supercells. So that shortwave moves in. That will be our main impetus for, main driving force for any severe convection along the dry line this afternoon. Let's go down to 850 millibars, see how that low-level jet progresses. And again, because we don't have a robust surface response or low-level response associated with this trough, this little shortwave, we're not going to have much of a low-level jet to speak of throughout the day. You see, we don't really see an increase throughout the day across the region until your typical nocturnal increase here across the southern plains. But overall throughout the day, not much to speak of. Just some pockets of maybe 30 knot flow in there, but mostly 20 knots or so of flow across this region, weakening with southern extent, which is why the hail threat is going to be greater down there due to weaker low-level shear. Let's go down to the surface, see how that surface pattern progresses as well. So you see in southeast Colorado some semblance of surface low already. We go forward with time. That surface low tries to deepen just a little bit. This is at 4 p.m. Central Daylight Time. Let me zoom in here just a little bit so you see our pattern. So here's our surface low, broad surface low here across eastern Colorado, seeping into northern New Mexico there. And our surface pattern fairly complex. If I shift to the southern sector, and you can kind of see it there already in that sector we just looked at. But you see the cooler temperatures out here across eastern Oklahoma. This is the result of that ongoing storm complex this morning. That is going to have a significant impact in the thermodynamics, especially with northern extent here. You see those cooler temperatures seeping into western Oklahoma, where that 5% was. That has decreased confidence in a robust severe threat up there, especially for western Oklahoma, probably the I-40 corridor northward. because of the ongoing storms there. Farther to the south, a little bit warmer temperatures. You see temperatures getting into the 80s, even 90s down there near that dry line, probably just west of that dry line. We do see a warm frontal zone, likely in here, the northern extent of that moisture return. You see the wind shift there seeping across the Red River into northwest Texas. That, I believe, will be the main focus for any tornadic activity today, especially given our weaker thermodynamics farther north. This low-level shear enhancement along the synoptic warm front here, or at least whatever this boundary is, will be a favorable area, a favored corridor for tornadoes, given fairly weak low-level shear elsewhere. Let's look at some soundings here. You see a fairly favorable look here on the 12Z NAM. You see some semblance of triple point develops. Here's your dry line stretching down here into western Mexico. And then you have your warm front up in here. So that triple point down here is going to be a favored location for storm development here this afternoon. This may help overcome any lingering thermodynamic issues from any morning clouds or storms down there, especially if we get a little bit of clearing. That enhanced convergence along that triple point. You see that moisture tongue feeding back up in here. That's a classic sign that you have that little triple point ongoing there. That is going to be a favored location, I think, for storm development, which is going to be somewhere, depending on where it sets up, probably somewhere in the far southeast Texas Panhandle to northwest Texas, even southwest Oklahoma. We'll just have to monitor where that triple point sets up today, and I think that's going to be your best bet for tornadoes going into this afternoon's event. Let's take a sounding out here. We'll take one down here from about Lawton, just ahead of that triple point. We'll also take one here down south along the dry line, maybe closer to the Abilene area here. And so here's your profile along that triple point. You see fairly decent instability. We do get, at least on this NAM run, some decent instability to build away from that morning convection. And again, not sure how this model has handled the morning convection. This is not really a convective allowing model. We can take a look at maybe some simulated reflectivity here, a convective precip, to see how it's handled this morning convection. It does have a nice blob there across central Oklahoma through much of the day, and continues to backbuild north of that warm front. So that is of some concern. This may be a little bit wonky. If we see less convection develop here, that may mean a better threat for convection down here in southwest to western Oklahoma. But again, we'll have to make sure and see how and look at our surface data to see how that progresses throughout the day. Any convection to the north of this warm front will reinforce it and not allow it to get as far north as previously forecast, which is why the NAM has it here somewhere down to the south along basically the Red River vicinity there going into the afternoon. We do see a signal there close to that warm front going into the afternoon hours, but not sure this is the absolute best initialization, but we will look at the overall pattern instead of nitpicking the fine scale details with this, the initializations of the morning convection. So this again is our sounding near the triple point, just to show you again where this was, right ahead of that triple point, far southwest Oklahoma. And you see a fairly favorable looking profile for supercells with all hazards. Fairly decent instability builds, about 2,000 joules per kilogram of mixed layer CAPE. Strong low-level instability as well, almost 150 joules per kilogram of 0 to 3 kilometer CAPE. And we also have a nice looking hodograph for all hazards. Somewhat weaker low-level shear. You don't see a ton of veering in that lowest kilometer, but you do see some significant veering with height of those winds, that clockwise curvature in the hodograph. There is some low-level shear there to speak of, so it would foster maybe a tornado or two with any storm there. About 40 knots of deep layer shear, so favorable for supercells. And we should see a large hail threat as well, especially earlier on when low-level shear may be a little bit weaker. And this would be indicated here in the 0Z sounding from farther south. A little bit stronger instability down along the dry line, 2,500 joules per kilogram of mixed layer CAPE, but much, much weaker low-level shear there with mostly straight hodographs, favoring supercells, about 60 knots of bulk shear given the stronger flow aloft down to the south. So supercells are a likelihood down there, significant off-boundary flow. Let's quickly take a look at that. Your dry line, how the shear vectors are oriented with respect to your initiating boundaries. You see the dry line there is somewhere in here, and your shear vectors are definitely very much perpendicular to that initiating boundary across the entirety of the dry line, it appears. So we should see a fairly nice window for discrete storms, especially with southern extent there along the dry line, and these would have a large to significant hail threat given very strong instability and weak low-level shear with a discrete supercell mode favored. So large hail going to be the main threat farther south, the southern portion of the risk area, especially in that yellow hatched area. places to the south and southeast of Abilene, west of the I-35 corridor from Waco to San Antonio. Places like Del Rio, Laredo, San Antonio, and Austin are in that 15 hatched area. Places like Brownwood, Fredericksburg, Kerrville, under the gun for the greatest hail threat there as well. And I think that is a pretty good bet given these profiles in place. Again, farther to the north, where low-level shear is a little bit stronger, we will have a chance for a tornado or two up in there. But again, it's all going to depend on how that atmosphere destabilizes near that warm frontal zone where the low-level shear is strongest. Here is some convective allowing model data from this morning and last night. This is the HRRR run, the 12Z HRRR, and the cams really have a tough time on days like today. Last night's cam suite was all over the place, did not have a singular solution, but we'll take a look at them just for kicks here. So this is the 12Z HRRR. It has that convection across Oklahoma continuing. Doesn't have much firing back in here across the southern Texas Panhandle into southwestern Oklahoma like what we're actually seeing now. Let me put it back there. Let me go up north to that northern sector so we can reference what's going on right now. And you see that additional development down to the southwest. This may move off pretty quickly, but we do see some storms and showers down here across the southern Texas Panhandle into the Texas South Plains moving into this area. So a decent initialization here with this 12Z HRRR run. But again, we have to take these with a grain of salt on a day like today where OBS are much more favored. So you see those showers kind of persist throughout much of the day across the region, including there in our triple point area across southwest Oklahoma. But the HRRR does fire a supercell or two down here in far northwest Texas, maybe the Childress to Vernon, maybe Turkey, Texas area that down there in the far northwest Texas region. Moves it into southwest Oklahoma. Does look pretty robust for quite a while, especially as it moves toward the I-44 corridor. So the HRRR is hinting at a long track supercell or two down across the Red River vicinity into northwest Texas into southern Oklahoma. So that is an interesting signal there. Let me go back just a couple of runs, see how it handled that as well, just to see how consistent it's been. This is a pretty decent initialization. Has quite a bit of convection there across Oklahoma, some showers moving in, and it looks like the HRRR does try to fire some supercells there. Not super long-lived. It is within this kind of showery plume here, though, which does make me concerned that this solution may not be 100% accurate, but it is something to take note of as well. We do see additional convection down here from western Mexico into southwest Texas, southwest and central Texas. Would have, again, more of a large hail threat, a little bit more clustered, not quite supercellular mode here on the HRRR. I don't think that's going to be a problem. I think we will see supercells down here given a favorable orientation of those shear vectors with respect to the initiating boundary, the dry line, and overall deep layer shear favorable for supercells. So I do think this clustery kind of cruddy looking convection is, we're going to see some more discrete supercells here before eventually storms may congeal into a line or clustered mode, but robust hail threat down there as well as a little bit of a damaging wind threat, especially including areas as far south as southwest of San Antonio there, Laredo, Uvalde, may be under the gun there for a hail threat as well. Let's take a look at some of the current models. This is the FV3 model that's coming in right now, the 12Z FV3. Again, this is not a great initialization. It doesn't really handle that ongoing convection well at all. Does have quite a bit of showery activity there. Does initiate some supercells here, again, in that same sort of spot, Turkey, Texas area in the southeast Texas Panhandle. And these remain pretty robust into western Oklahoma. Pretty long track supercell there. Eventually, according to this model, tracking toward the OKC metro. So we'll have to watch that for sure. But at least a couple of models now are hinting at some sort of robust development down here in the southeast Texas Panhandle, northwest Texas, southwest Oklahoma vicinity, which is interesting to say the least. Additional convection to the south here across central Texas from western Mexico as well, with a large hail and eventually a damaging wind threat there. See if any other models are in yet. So we do have the WRF ARW that is out a little bit here for us. Again, we're taking a holistic approach, or an ensemble approach, with these convective allowing models. We don't want to look at just one. We want to look at multiple to see how they're performing among the entirety of the model suite. So not bad here. It does initiate some convection out there. This is interesting, though. Another model that has a supercell out here in the southeast Texas Panhandle. So all the models here are hinting at some sort of robust development there up near that warm front in the southeast Texas Panhandle. That is very interesting. Now, we've had 3 models showing a signal here, and that is pretty good confidence that we may have an enhanced threat down here from the southeast Texas Panhandle and southwest Oklahoma, northwest Texas. That road lasts for quite a while, then additional development down here along the dry line with a hail threat and damaging wind threat. Let's take a look at the NSSL WRF here, see what it shows. Handles that convection decently well, quite a bit of convection here, even sprouts some more here throughout the early afternoon hours. And then once again, interestingly enough, not elevated, but enhanced area of supercell potential here in that same spot. So multiple models now, all of the convective allowing models, it looks like, are pinpointing a supercell threat down here in that same area. And then, of course, down here along the dry line, supercells with a hail threat as well. One last convective allowing model, the NAM 3 kilometer CONUS, 3 kilometer. I don't look at this model very often, but we'll look at it here just since we're taking a kind of an ensemble approach here. So we'll look at it just for kicks, pretty much. But again, I don't put a lot of stock into this model. It never does a great job handling convective mode. So it has that convection in Oklahoma sustaining throughout the afternoon, and once again, a supercell threat down here. Does fire supercells there in the southeast Texas Panhandle. So that is quite the signal for a severe threat down there in the southeast Texas Panhandle. Given the trends here, given that all of these convective allowing models, given that our meteorology is showing a threat for an enhanced threat for supercells down here in this vicinity, I would not be surprised if they put back in that 5% risk area down there, perhaps even honing in on a greater threat, an enhancement of the overall threat for severe storms down there in that southeast Texas Panhandle, northwest Texas, southwest Oklahoma vicinity for today's event. So for now, we do just have a slight risk level 2 out of 5. It extends from far northwest Oklahoma, the Kansas-Oklahoma border, places like Woodward, down toward the western half of Oklahoma. That does include the Oklahoma City metro area, Lawton, down toward that area as well, into the eastern Texas Panhandle, and then that slight extends all the way down to the Texas-Mexico border, central Texas, places like Abilene, Waco, Austin, San Antonio, over to Fredericksburg, Kerrville, Brownwood, Brady, and then down toward the border, Del Rio, Uvalde, Laredo, under the gun for that slight risk as well. Tornado threat, again, we could see that increase if the SPC sees fit in that kind of northwest Texas vicinity later on. But for now, just a 2% risk up in here for western Oklahoma. I think these lines will shift by the next outlook, which comes out at 11:30 a.m. I do think we will see these lines shift, perhaps a cut. They will cut this northern extent off and perhaps put in a 5% down here for this region as well. But for now, a 2% extending across the eastern Texas Panhandle into much of western Oklahoma, far northwest Texas there. And then a damaging wind threat. They may increase this as well, but overall just a marginal damaging wind threat, but large hail going to be the threat as well within that slight risk area, especially down to the south from the Texas-Mexico border into central Texas, where there is a threat for significant severe hail with any supercells there. So that's going to do it for this video. Thanks for watching, and we'll see you in the next one.